Hello, my name is An. I'm from Group 2. My matrix number is 212965. And now I'm going to summarize Chapter 1. In Chapter 1, we got chapter outline. The first chapter outline is mechanics. The mechanic is a study of what happens to a body when forces are applied to it. The mechanics are separated to three parts: rigid body, deformable body, and fluid. Below the rigid body has static and dynamic. Below the fluid has incompressible and compressible. The static means at rest, while the dynamic means accelerated motion of body. The second chapter outline is fundamental concept. In this chapter outline, we learn about basic quantity. The basic quantity has length, mass, time, and even force. Besides the basic quantity, we learn that the meaning of the particle, rigid body, and the concentrated force. In fundamental concept, we also learn about Newton's law of motion, which are the Newton's first law and Newton's second law, and last is the Newton's third law. And even we learn about the Newton's law of gravitational attraction in this equation. And the third chapter outline is unit of measurement. In this chapter outline, we learn about SI unit. For example, of the SI unit is the length in meter, m, time in second s, and mass in kilogram kg. The fourth chapter outline is the international system of units. Prefix is the tool that can be modified large or small numeric quantity. We can replace the value of 1000 with 1k. Numeric calculation is the fifth chapter outline of the chapter 1. In this chapter outline, we learn about dimensional homogeneity, significant figure, and the last is rounding off the number. The last chapter outline is the general procedure for analysis. We learn how to solve the problem. It is important to present work in a logical and orderly way are suggested below. For example, convert 2 km per hour to meter per second. We can cancel off the kilo per meter and cancel off the hour, and we get the final answer is in meter and per second. That's all from me. Thank you.
My name is Ravirman. My metric number is 212348. Today I'm going to summarize Chapter 2 Force Vector that we studied in the week 1 to week 7.
I'm going to explain about the first subtopic, scalar and vectors. Scalar is a physical quantity that has magnitude only, while the vector is a physical quantity that has both magnitude and direction. To explain about the second subtopic, vector operation. Vector operation consists of vector addition and vector subtraction. Is vector addition of forces. Vector addition of forces consists of three methods. First method is parallelogram method, second method is collinear, and third method is triangle method. To solve the problem, we also use the trigonometric formulas. The first formula is cosine law, and the second formula is sine law. Now I'm going to talk about the fourth subtopic, addition of system of coplanar forces. This subtopic consists of scalar notation and Cartesian vector notation. Scalar notation is a notation that consists of only magnitude, while the Cartesian vector notation consists of vector I and j. These unit vector I and j have magnitude of 1. Then we also learn about the coplanar force resultants. To find coplanar force resultant, first we must resolve force into x and y component. Then we must add the respective component using scalar algebra. Finally, the resultant force is found using the parallelogram law. In the meantime, we also need to find the magnitude of the resultant force and the direction of the resultant force. Topic is Cartesian vector. The Cartesian coordinate system, which consists of x, y, and z axis, can be represented by the right hand rule. Next is rectangular components of a vector. From this, we know that the vector A can be represented in terms of x, y, and z component. Next, we learn about the unit vector. The formula for the unit vector is the vector divided by its magnitude. Next is Cartesian vector representation, where a vector A can be represented by the unit vector I, j, and k. To find the magnitude of Cartesian vector, this is the formula for the magnitude. The direction of Cartesian vector. The direction of Cartesian vector can be calculated by the formula below. So for the alpha is the angle between vector A and the x component of A, and gamma is the angle between vector A and the z component of A. Beta is the angle between vector A and the y component of A. Is addition and subtraction of Cartesian vector. So in order to find the resultant force in terms of Cartesian vector, we need to find the resultant value of x component, y component, and z component separately. The seventh subtopic is position vectors. Position vector R is defined as a fixed vector which locates a point in space relative to another point. This position vector needs to be represented in Cartesian vector. The eighth subtopic is force vector directed along a line. The force can also be represented in terms of Cartesian vector. So this is the formula for this force vector directed along a line. So the vector F is equals to the magnitude of x times by the unit vector. Subtopic is dot product. The dot product of vector A and B can be written as A dot B. The formula for the dot product A dot B is the product of magnitude of vector A and vector B with the sine theta. Subtopic, we also learn about the laws of operation. There are three laws. First one is cumulative law, second one is multiplication by scalar, and third one is distribution law. We also learn about the Cartesian vector formulation, where we learn two things: dot product of Cartesian unit vectors and dot product of two vectors, which is A and B.
Assalamualaikum and good day. My name is Muhammad Hushaini bin Kamar Zaman and my metric number is 213141. I will summarize topic 3 in statics called equilibrium of a particle. This topic has 4 other subtopics with the same objective, which are to understand the concept of free body diagram, or can be called as FBD, and solve particle equilibrium problems by using equation of equilibrium. First subtopic is condition of the equilibrium of a particle. The meaning of equilibrium is the particle at rest or moving at constant velocity. There is a law of motion that obey the condition, which are Newton's first law and second law of motion. First law, sum of F equal to 0, and second, sum of F is equal to ma, which at constant velocity, the acceleration will become 0. Second subtopic is the free body diagram. We need to draw the problem as simple as possible, that free from surrounding. In our syllabus, it has two common connections, which are spring and cable and pulley. First is spring. The formula for spring is F equal to Ks, where K is the stiffness of the spring and S is the length of elongation or compression. Second is cable, where normally the weight will negligible and it cannot be stretched. Tension always act in the direction of the cable. For any angle, cable subjected to tension are the same for both as long as it connected at the pulley. To draw the free body diagram, we need to follow the procedure. It has 3 steps. First, we need to draw the outline shape, then show all the forces, both active and reactive. And last one, identify each forces. If it is known, then show the magnitude and direction. However, if it is unknown, show the letters to represent it. Third subtopic is coplanar system. We should subject the particle into x and y plane, then resolve the forces into its component, like sum of force x and sum of force y. It is required for scalar equation. Procedure to analysis the problem are to draw the free body diagram and solve the unknown in equation of equilibrium that we have sum, just like the steps that I have mentioned before. Last subtopic is three-dimensional force system, which this one is slightly similar with subtopic 3. Subtopic 3 is for two-dimensional problem, but this one is for three-dimensional problem, which require another one axis, which is z-axis.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Azam Doban Rosdi with metric number 210154. Today I'm going to I'm gonna explain briefly about chapter 4, force system resultant. This chapter is we have been learned this chapter with Dr. Ruby, if I'm not mistaken. So this is just a summarize of the topic. Right. So let's go first on the chapter what we have. First we have moment of a force. So this one is scalar formation. So what it is about we need to know about the moment first. Moment is basically a force at a point or axis, a measure of the tendency of the force to cause a body to rotate about a point of or axis. It's like on a wheel we have steering. Yes, that is one of the example. So next we have torque. What is it? In the car automotive sector, we always talk about torque. So what it is actually tendency of rotation caused by Fx or simple moment m origin. So we there's not a lot of things we need to know. In it we have magnitude we need to know. Mo equal to Fd, which is F is force, D is distance. Yes, displacement distance. So the unit is Newton meter. The direction we have, we need to use the right hand rule. Use our hand and just make a grip and use our thumb to point upward. It's like that, upward or inward, depend on the situation. And also the last one we have resultant moment. So the formula is MRO is equal to sigma FD. Sigma means the total of the force and displacement that we have in a situation. So next we have cross product. So in this cross product we have three things we need to remember. This is so simple. This is so shortened from the cross product itself. Just the first is magnitude. For the magnitude between angle between when the theta is located between 0 to 180 degrees, so we use the formula of C equal to AB sin theta. So how about the direction? So the direction is just like right now, just now, which is we use the right hand rule, still same, and we have a little bit law of operation. This is slightly different from the dot product because cross product is literally different name, so different kind of law. So what law did we have? It actually A times B is not equal to B times A. Yeah, this need some of explanation, but this what we need to study by our own. So another thing is A times B is equal to negative B times A. Yes, this may look weird, but this is the fact. Yeah, that we need to admit. So so we need to obey to this law. Okay, no disagreement. Okay, so B times A is equal to negative C. Yeah. Next, we have moment of force. This time is slightly different because just now is scalar formation. This time is vector formulation. So in this vector, we know that different is in vector we have magnitude and also the direction. That is the different. So the formula is MO is equal to R times F. R is basically the distance, not mistaken. So the magnitude is MO is equal to RF sin theta, and direction also depending, MOR depending on the right hand group. So simple for us to remember about that. Next, Cartesian vector formulation. So in the Cartesian formulation, Cartesian vector formulation. So first of all, we need to do just like this. which is MO is equal to RF, and then we will have this kind of first before we converted it into this kind of form with the determinant expanded. When we expanded the determinant, it will be like this. We just basically take the Rx fx and then we times with the we need to adjust this. We need to adjust this just like ry fz and rz fy. We need to cross it. Yes, we need to cross it, and then we times with the I and Rx. This is what we have been learned in the matrices that we need to apply in this subtopic. So I think that is all from me. Thank you very much, everyone.
Hello, my name is Norman Amirul bin Jasni, matrix number 211989. Today I want to summarize about topic 5, equilibrium of a rigid body. Firstly, we need to know about the conditions for rigid body equilibrium. The equilibrium of a body is expressed as these equations. Fr equals to sum f equals to 0. Basically, all this equation is equal to 0. Then consider summing moments about some other point, such as point A. We require these equations. Okay. Then we need to know about free body diagram. Firstly, about support reactions. If a support prevents the translation of a body in a given direction, then a force is developed on the body in that direction. If rotation is prevented, a couple moment is exerted on the body. This is types of support reactions. Firstly, we have roller, fixed, pin, and simple. Then internal force. External and internal forces can act on a rigid body. For FBD, internal forces act between particles which are contained within the boundary of the FBD are not represented. Thirdly, particles outside this boundary exert external forces on the system. Then weight and center of gravity. Each particle has a specified weight. System can be represented by a single resultant force known as a weight W of the body. Location of the force application is known as the center of gravity. And the equations of equilibrium. For equilibrium of a rigid body in 2D, we have these equations. Fx and Fy represent sums of x and y components of all the forces. And this MO, M naught, represents the sum of the couple moments and moments of the force components. Alternative sets of equilibrium equations for coplanar equilibrium problems. The equation is same with this 2D rigid body. Sum fx equals to 0, component fy equals to 0, and component m naught equals to 0. Two alternative sets of three independent equilibrium equations. We have sum of fa equals to 0, then sum of ma equals to 0, sum of mb equals to 0. Two and three force members. Firstly, we need to know about two force members. When forces are applied at only 2 points on a member, the member is called a two force member. Only force magnitude must be determined. This is the example of two force members. So we can see the force have two. We have two force in this body, FA and FB. Then three force members. When subjected to three forces, the forces are concurrent or parallel. This is the example of three force member. As we can see, it have F1, F2, and F3. Constraints for a rigid body. Redundant constraints. Redundant constraints more support than needed for equilibrium. Statically indeterminate. More unknown loadings than equations of equilibrium. Then we have improper constraints, instability caused by the improper constraining by the spots. When all reactive forces are concurrent at this point, the body is improperly constrained.